All right, let's look at the homework 9, problem number 10. All right, it says this: the manufacturer of hospital supplies has a uniform annual demand for 80,000 boxes of bandages. It costs $20 to store one box for 1 year, and it costs $500 to set up the plan for production. How many times a year should the company produce boxes of bandages in order to minimize the total storage and the setup costs? All right, so let's do that. All right, let's let X be the number of productions or or we can say setups per year. All right, so that means that it produces X times a year. All right, so let's find the cost function. I'm going to call it, say, C of X. All right, so storage cost. All right, so if it's produced X times a year, so we have to divide 80,000. All right, so that's the total demand, and divide by X. All right. So this is the number of boxes produced per production. All right. Then on the average, the half of that will be stored. So instead of 80,000, I'm going to actually put 40,000 because it's on the average, half of that will be stored. All right, and it costs $20 to store, so you multiply by 20. All right, we have that. So this would be our storage cost. All right. And how about the setup? All right, setup cost would be pretty simple because it costs $500 per setup, and we're going to have X of those per year. All right, so if you simplify that, let's say clean it up, 2 times 4, and so it's going to be 800,000 over X plus 500X. All right, we want to minimize this function. All right, so let's find the critical number. Take the derivative. All right. Derivative is going to be, I don't like the way this is written, so I'm going to actually rewrite it as 800,000 x to the negative 1. All right, so the derivative would be, so 800,000 is just a number. All right, derivative would be put the negative sign in front, x, subtract 1 from the power, so it's negative 2. All right. And the derivative of 500x would be 500. All right, and then if you rewrite that, it's going to be, this is going to be negative 800,000 over x squared, right? Because negative, so you put it on the bottom. So plus 500. All right, set that equal to 0. And then, let's see, we can add 800,000 over x squared to both sides. We get the 500 is equal to 800,000 over x squared. And then multiply both sides by x squared. So you have a 500x squared is equal to 800,000, right? Then I can divide it through by 500 to get x squared is equal to 800,000 divided by 500. All right, so what's that? So 2 zeros, we can knock those out. Right, 8, you can squeeze one of those. And 30, so it's a 6, and then you have to have, right? So it's 1600, right? If you take the square root of both sides, we get x is equal to plus or minus 40, right? But of course, we can't really talk about negative production, so it's going to be positive 40, right? So we would like to produce 40 times, right, a year. So you put 40, right? Check the answer. We got that. All right, actually, I forgot to check that it's actually going to produce a minimum. All right, we can actually do, number line. And here's a x. Then we can try x is 40 is the critical number. And here's a 0. And we can look at C prime. And we can try like x equals 1 and x equals 41 or something like that. All right. Then you see that if you plug in 1 here, and the derivative is going to be negative 800,000 plus 5, so it's definitely negative, right? If you put 41 here, this is going to be positive, right? Which means that the original cost function is decreasing here and increasing here. So we know that the minimum happens at x equals 40, right? So, oops. Let's see. All right, that's it. I hope that this was clear.